It all happened in just a few moments, but those moments may end up changing Venezuela for years. Yesterday evening, the ground suddenly gave way in northern Venezuela. At first, scientists reported the earthquake as a magnitude 7.1. Not long after, they updated it to a 7.2. That alone would have been one of the biggest earthquakes the country had experienced in more than a century. But the worst part hadn't even happened yet. Only about 40 seconds later, before people could make sense of the first quake, a second one hit. This time, it measured magnitude 7.5. Think about that for a second. 40 seconds isn't enough time to get down several flights of stairs. It's not enough time to get outside a building. Most people were still trying to figure out why everything was shaking when the second, even stronger earthquake slammed into the same area. For people living in Valencia, San Felipe, Puerto Cabello, and the nearby towns, there was almost no chance to react. The first quake was already terrifying. Then the second one arrived, while everyone was still standing in the middle of the first disaster. These weren't two random earthquakes. Both ruptured along the same fault corridor, right where the Caribbean plate and the South American plate meet. That's what makes this event so important. The fault didn't just break once. It broke twice in rapid succession. Together, these two earthquakes created the strongest seismic sequence Venezuela has seen in well over 100 years. The numbers alone are alarming, but that's not what worries experts the most. The real danger is where these earthquakes happened. They struck close to some of the country's most populated communities, where hundreds of thousands of people live, work, and travel every day. A powerful earthquake in a remote area is one thing. A powerful earthquake beneath busy cities is something completely different. Another major factor is how shallow these earthquakes were. The ruptures happened only about 13 kilometers below the surface. That's incredibly shallow for an event of this size. Because of that, much of the energy traveled almost straight into the ground above, instead of fading out deep underground. That means the shaking people felt wasn't just strong, it was violent. Buildings, roads, bridges, and older structures had to absorb nearly the full force of the earthquakes. And when that happens in densely populated areas, the risk of serious damage rises dramatically. This wasn't just another large earthquake on a map. It was a worst-case combination of powerful shaking, shallow depth, and heavily populated city soil unfolding in less than 1 minute. To really understand why this earthquake was so dangerous, you have to understand one term: earthquake doublet. Most people think a big earthquake happens once, then it's over. That's usually how it works. But this wasn't one of those cases. An earthquake doublet is when two powerful earthquakes happen almost back to back, in nearly the same place. It's rare, and when it does happen, it tells scientists that the fault underneath wasn't finished moving. In this case, the magnitude 7.2 earthquake was what seismologists call the foreshock. The magnitude 7.5 that followed was the main shock. That difference matters. The first quake didn't release all the pressure that had been building underground. Instead, it shifted a huge amount of stress onto the next section of the fault. That neighboring section was already under incredible pressure. It was basically sitting at its breaking point. The first rupture was all it needed. Once that extra stress hit, the second section gave way almost immediately. That's why the larger earthquake struck only about 40 seconds later. Those 40 seconds tell us something important. This wasn't bad luck. It was a fault system that was already primed to fail in more than one place. And that's what makes this sequence so dangerous. Imagine you're inside a building. The first earthquake hits. The walls crack. Windows break. The structure is already weakened. People are trying to figure out what's happening or looking for a way out. Then, before anyone has a real chance to react, a second and even stronger earthquake slams into the same building. That's exactly what happened here. Buildings that survived the first shaking suddenly had to absorb an even bigger hit. Structures that might have stayed standing under one earthquake were pushed past their limits by the second. This is why earthquake doublets often cause much more damage than a single quake of the same size. It's not just about how powerful the earthquakes are. It's about the timing. The second quake hits when everything is already vulnerable. Buildings, roads, bridges, and most importantly, people. That's why these events are so deadly. The first quake creates the damage. The second one takes advantage of it. Northern Venezuela experienced both in less than a minute. And that's one of the biggest reasons experts are taking this disaster so seriously. What made these earthquakes so destructive wasn't just how powerful they were, it was where they happened and how close they were to the surface. Both earthquakes struck on land, not out in the ocean. And they happened at a depth of only about 13 kilometers, or roughly 8 miles. That may not sound very close, but in earthquake terms, it's extremely shallow. When an earthquake happens much deeper underground, some of its energy fades before it reaches the surface. But that's not what happened here. These quakes were so shallow that most of their energy traveled almost straight into the towns and cities above them. That's why the shaking was so intense. The USGS estimated the strongest shaking reached between 8 and 8.5 on the modified Mercalli intensity scale. That's classified as severe to violent. At that level, the damage can be widespread. Walls crack open. Older buildings can collapse without much warning. Roads split apart. Bridges become unsafe. And on steep hillsides, the ground itself can give way, triggering dangerous landslides. This isn't the kind of shaking where people simply run outside and wait for it to end. It's the kind that changes entire neighborhoods in less than a minute. The hardest hit areas are expected to be the cities closest to the epicenters. Valencia, one of Venezuela's largest cities, sits only a short distance away. Puerto Cabello, an important port city, is also inside the zone of severe shaking. San Felipe and several nearby communities were hit just as hard. These are the places where the worst structural damage is likely to be found. And that's where another problem begins. Right after a major earthquake, getting help to the people who need it most isn't easy. Roads can be blocked by debris or landslides. Bridges may no longer be safe to cross. Power outages and damaged communication networks make it difficult for emergency crews to figure out where people are trapped. In the first few hours, rescuers are often working with very little information. They know people need help, but they can't always reach them. That's why the first reports after a disaster like this rarely tell the whole story. Damage assessments take time. Rescue teams have to clear roads, inspect unstable buildings, and search one area at a time. When an earthquake is this shallow and this close to major population centers, every minute matters. The shaking may stop in less than a minute, but the rescue effort can last for days, and sometimes much longer. That's the reality northern Venezuela is facing right now. The earthquake itself was only the beginning. What happens in the hours and days that follow will determine just how severe this disaster ultimately becomes. As rescue teams were still trying to figure out what had happened, another warning came out that caught a lot of people's attention. The U.S. Geological Survey issued a red alert. Now that doesn't mean they were saying tens of thousands of people had already died. That's a common misunderstanding. The red alert comes from a system called PAGR, which stands for Prompt Assessment of Global Earthquakes for Response. It doesn't count victims. Instead, it estimates what could happen based on everything scientists already know. The system looks at the earthquake's magnitude, its depth, where it happened, how many people were exposed to the shaking, and how buildings in that region have performed during similar earthquakes in the past. When all of those pieces are put together, the model estimated that this disaster had the potential to cause somewhere between 10,000 and 100,000 casualties. That's not a confirmed death toll. It's a statistical forecast. Think of it as a worst-case warning based on historical data, not a final report from the ground. In the first few hours after the earthquakes, officials confirmed only a few dozen deaths and several hundred injuries. As tragic as that already was, experienced disaster responders know those early numbers almost always change. Why? Because the communities closest to the epicenter are often the hardest to reach. Roads may be blocked, communication systems can fail. Rescue crews need time to search damaged buildings, and many victims aren't found immediately. History has shown this over and over again. The first reports after a major earthquake almost always underestimate the true scale of the disaster. Another thing that's easy to miss is that the Richter magnitude isn't what decides how deadly an earthquake becomes. A powerful earthquake in an empty area can cause very little loss of life. A slightly smaller one beneath a crowded city can become a national tragedy. What really matters is how many people are living nearby, how well the buildings were constructed, and how quickly emergency crews can reach those who are trapped. Those three factors often matter more than the number printed on the earthquake scale. In this case, the situation became even more difficult when damage forced the closure of the main airport serving Caracas. That immediately slowed the arrival of outside rescue teams, heavy equipment, medical supplies, and humanitarian aid. Every hour matters after a major earthquake. Delays can cost lives. Even Caracas, located well away from the epicenter, wasn't spared. Several buildings collapsed, proving just how far the shaking reached. If damage was that serious more than 100 miles away, it's easy to imagine what communities, much closer to the fault, may have experienced. That's why experts remain so concerned. The earthquake is over, but the full picture of the damage is still unfolding. And in disasters like this, the real story usually becomes clearer one day at a time. To really understand why this earthquake has scientists so concerned, you have to look at where it happened. Northern Venezuela sits right on the boundary between the Caribbean plate and the South American plate. These two massive pieces of Earth's crust are constantly sliding past each other. They only move a couple of centimeters each year, but over decades and even centuries, that slow movement builds up an incredible amount of stress underground. Eventually, something has to give. That stress is released along several major fault lines that cut across northern Venezuela. The most important ones are the San Sebastian Fault, the Moran Fault, the El Pilar Fault, and the Boconó Fault. These aren't new faults. They've been shaping the country's history for hundreds of years. One of the darkest examples happened in 1812. A massive earthquake devastated much of the region, including Caracas and nearby cities. Historians estimate that around 30,000 people lost their lives. At the time, Venezuela's population was only a fraction of what it is today. That's the part that's hard to ignore. The fault system that moved this week is part of the same tectonic boundary responsible for that historic disaster. It didn't disappear after 1812. It has been quietly storing energy ever since. And history shows this isn't an isolated event. In 1967, a magnitude 6.6 earthquake struck near Caracas. It wasn't nearly as powerful as the earthquakes we're talking about today, but it still killed hundreds of people and caused major damage. The lesson was simple. In this part of Venezuela, even a moderate earthquake can become deadly if it hits close to a densely populated area with vulnerable buildings. Then came the 1997 Cariaco earthquake, another reminder that these faults are still very much alive. More recently, in 2018, Venezuela experienced a magnitude 7.3 earthquake. On paper, that's very close to the size of this week's event. But the outcome was completely different. Why? Because the 2018 earthquake happened offshore and much deeper underground. By the time its seismic waves reached cities, they had already lost a significant amount of energy. The shaking was still noticeable, but it wasn't nearly as destructive. This week's earthquakes were the exact opposite. They were shallow, they happened on land, and they struck close to major cities. That combination changes everything. Instead of losing energy before reaching people, the shaking traveled almost directly into neighborhoods, businesses, schools, roads, and hospitals. That's why experts aren't just looking at the magnitude, they're looking at the location. The fault didn't produce an unusually large earthquake by global standards. It produced one in almost the worst place possible. And that's exactly why this event has become one of the most serious natural disasters Venezuela has faced in generations. Even though the strongest shaking has stopped, this story is far from over. Within just the first few hours, seismologists had already recorded around 20 aftershocks, and that's exactly what they expected. After a magnitude 7.5 earthquake, aftershocks don't disappear overnight. They can continue for weeks, months, and sometimes even years. Most will be smaller, but some can still be powerful enough to cause serious damage. That's why the danger isn't over. A building that barely survived the main earthquakes may not survive the next strong aftershock. Walls that are already cracked can suddenly give way. Bridges that look stable today may become unsafe tomorrow. The same goes for the mountainsides. The main earthquakes likely loosened a lot of rock and soil. If heavy rain moves into the area, landslides could happen with very little warning. That's also why experts keep telling people not to rush back into damaged buildings. It's understandable to want to check on your home or belongings, but going back too soon can be one of the most dangerous decisions you make. At the same time, a lot of rumors have already started spreading online. Some people are claiming these earthquakes are connected to the recent quake near Japan. Others point to California. Some even blame solar storms or talk about a worldwide earthquake chain. The science simply doesn't support those claims. Earthquakes happen every day around the world because each fault has its own history and its own buildup of stress. A major earthquake in Venezuela doesn't mean another one in Japan or California caused it. And solar activity doesn't generate enough force to trigger a magnitude 7 earthquake. What happened here has a much simpler explanation. This was the result of stress building for decades along the boundary between the Caribbean plate and the South American plate until the fault finally broke. So what should we be watching now? First, the confirmed casualty numbers, because they will almost certainly change as rescue crews reach the hardest-hit communities. Second, the aftershock sequence. A strong aftershock, possibly around magnitude 6, is still a real possibility. And finally, the damage assessments coming out of Valencia, San Felipe, Puerto Cabello, and the surrounding towns. Those reports will tell us how severe this disaster truly is. More than 200 years ago, this same fault system claimed the lives of roughly 30,000 people. Now, it has moved again. Not once, but twice, just 40 seconds apart. At this point, the biggest question isn't how powerful these earthquakes were. We already know the answer to that. The real question is how much more these communities will have to endure in the days ahead. And unfortunately, that answer is still unfolding.